So many materials around us are in fact mixtures of two or more substances. So it's very rare or very hard for us to find materials that are just made up of one pure element or one pure compound. More often than not, you're going to find them as mixtures or what we call these solutions. And by definition, solutions are these homogeneous mixtures of two or more substances. So the key here being the word homogeneous, and what we mean by that is these substances can mix really well, and the composition and properties are uniform across the entire solution. So the simplest example of a solution is air. Air is all around us, and it's a homogeneous mixture of these gases: nitrogen, oxygen, carbon dioxide, hydrogen, and so on. And these gases mix really well. And then you have drinking water, for example. So drinking water is not just a bunch of water molecules. It's water along with, dissolved gases like oxygen and carbon dioxide. It has minerals and salts to some extent, depending on, where that water is sourced from, where it is coming from. So all these are homogeneously dissolved in water. So on the other hand, if you take oil and water, for example, these cannot form a solution, not a solution, because these are two immiscible liquids. They're not going to homogeneously mix with each other. So some simple terminology here. So whatever solutions you're talking about, the substance that is present in the largest quantity in that solution or greatest quantity is called a solvent, and all other substances that are dissolved in the solvent are called the solutes. So depending on whether the solvent is a liquid or a gas or a solid, the solutions are classified as solid solutions or liquid solutions or gaseous solutions. So nothing creative there, but just wanted to make a note. So solid solutions are then solutions that have a solid as the solvent. So one example for solid solutions will be metal dissolved in metal. Example: metal dissolved in a metal. So if you take gold, for example, gold is a really soft metal, and it's a little too soft for its own good, a little too malleable and ductile, so it's not often used as pure gold. So what people do is they generally add copper or nickel or silver to gold in really small amounts to make it stiffer, harder, and stronger, and that's how most of the gold jewelry is made. So another example of let's say metal dissolved in metal would be steel. And steel is not all iron, and it has, obviously the solvent here is iron. And then it has elements like chromium and carbon and manganese and so on. So depending on what the specific application for the steel is, so you can make different solid solutions out of these metals. You can also have gases dissolved in a solid solvent. That is also a solid solution. So for example, hydrogen dissolves in many metals. So this can actually be really bad for the metal in many cases, because hydrogen tends to make the metal brittle. So in any case, we can talk about many such examples here. But so one important thing for us to note here is the composition of these solutions. So it not only matters to look at what the constituent substances are in a solution, but also how much of each of these solutes is present in that solution. So the concentration of these solutes is really important. For example, in alcoholic beverages, it has water and ethanol and some other solutes. So the concentration, we want to find out if it is at an acceptable level or not. So similarly, we've also talked about salts dissolved in water. So for example, if you were to look at the presence of fluoride ions in water, so fluoride ions, if the concentration of fluoride ions is, let's say, at 1 ppm, this is in fact proved to be good for tooth issues. Like it actually prevents tooth decay. So, but if it is, let's say, at 1.5 ppm, if it is greater than this, then the teeth can really go bad. They can become spotty or mottled. and even higher concentrations of fluoride ions can actually be very poisonous. So you get the idea here. The concentration of these solutes in solutions is really important to understand. So what we're going to do in the subsequent videos is we are going to spend most of our time talking about liquid solutions where the solvent is a liquid, and we'll talk about their properties like vapor pressure and the other colligative properties, and we'll also learn how to express the concentration of solutes in a solvent.